simulation. Today we are going to design and simulating open loop boost converter in MATLAB Simulink. Hope you have subscribed the channel to get the notification. So this is the boost converter circuit. You can see that this is the input supply where this is the output. This is capacitor, diode and inductor, and this is the switch. So this input could be battery, solar panel or rectifier output. Whereas if you see the output also battery or load like R load is resistor load or DC motor. Also it can be rectifier input. Then there is a MOSFET or IGBT for the switch. Whereas for the diode we can use normal diode for low frequency and Schottky diodes for high frequency. Where this is the inductor to reduce the current ripple, whereas the capacitor will reduce the voltage ripple. So let us see the working of the boost converter. When switch is turned on, you can see there is a DC supply which charges the inductor, so inductor current start increasing, whereas the diode will open circuit because this is a ground, so due to the ground it will be open circuit, so there will be no current flow. But when switch is off, so current start flowing to this diode, so you can see that current start flowing here, and also current start decreasing since inductor discharge through the load, whereas uh, there is a current flow in diode and also current flow in same current will flow through the inductor. So this is the basic formula, means output voltage equal to V in by 1 minus D, whereas D is equal to duty cycle, whereas this is a L value, minimum in inductor value. So Vs into D, Fs into delta I0, where Fs is equal to switching frequency, delta I0 is equal to ripple current, whereas this is formula for C. Same delta V0 is equal to ripple voltage. Let's design the circuit. So we have to design the open loop boost converter having input supply is equal to 75 volt, means V is equal to 75 volt, whereas average output voltage and current should be maintained at 300 volt and 5 ampere. The maximum voltage and current ripple is 5 volt and 1 ampere with Fs, means switching frequency 10 kilowatts. By using this formula we have calculated duty cycle is equal to 0.75, whereas I0 is equal to 5 ampere it is given. So using this formula we got the L minimum value is equal to 5.625 millihenry, whereas C minimum is equal to 75 microfarad. So what component we will require during the simulation? Of course this is DC supply. RLC branch, in RLC branch we will choose inductor, this is diode, this is load also, so and this is capacitor, this is switch. We are using MOSFET as a switch. So let's move toward the simulation. Already placed the all component here. As you can see that this is the input supply having magnitude is 75 volt, whereas this is the inductor as we calculated. This is a capacitor, and then this is a MOSFET switch, and then this is a diode, and then yeah, these are the current measurement. These are the three current measurement. This is for inductor current measurement, this is for the diode current measurement, this is for the output current measurement. As you can see that these are the blocks, these are the just like a connector, go to and from. Instead of connecting directly from here to here, what we can do is we can take one go to block and then from block. So we can change the tag by double clicking it. So if you want to search it, just go to the library and type it go to, so you will get this go to and from block. Okay, regarding the load, I took it 75 ohm resistance. These are the parameter: inductor current, diode current, output voltage, and output current and output voltage. Whereas this is our main block. This is a D mux, so that at once we can calculate, we can see the whole values. This is a display block from which you can see the readings. Ignore this block, this is not for use, but it will be going to use in closed loop operation, so don't worry about this one. So let's run the circuit. So meanwhile I will tell you that regarding the power GUI block, I took discrete time step at 1 e raised to power minus 6, mean 10 raised to power minus 6.
Whereas if you see the solver which I used is here, the solver is ODE23SG. So, and then yeah, so, and this is main block as I explained. So almost our circuit is done. So as you can see, the output voltage for the last one in the output voltage which is maintained constant at almost 300 volt. For the duty cycle is 75%. As you can here, the duty cycle is 75% with switching frequency 10 kilohertz. So let's see the waveform. So this is the inductor current waveform which is continuous, and then this is diode current waveform. As I showed you that diode current is like this, and then this is output current constant almost 4 ampere, and output voltage at 300 ampere. So that's all for today's guys. If you haven't subscribed the channel, please subscribe so that you will get the notification on next video. Bye bye.